Over here, most of the girls are sitting over here. All these girls are working on common bean in the University of Courtly Agriculture Farm, and they actually characterized these genotypes on the basis of their morphological performance. And on the right side, we had actually put some pots and potted experiment to cross them, to know about their flowering time and to know about their pollination behavior. We did some biochemical analysis as well. Which are the best genotypes on the basis of the nutritional performance? So we can select them and then we can breed them, or we can even select and give them to the farmers to grow a better, high-yielding, better nutritional variety. We did some molecular studies as well. It's only the second year of our project. We are going through these molecular estimations, but there is contrasting biodiversity that needs to be improved through hybridization. These were the markers we used. These are the primers we used, SSR primers we used to characterize the genetic diversity of beans. The statistical tools we used, and it is difficult to see the results of their name. I can't name from here that which genotype is better, but the seeds, according to the seed shape, seedling vigor, and some other traits on the basis of morphological performance, we screened 30 genotypes which were promising. Out of 166, the most promising means they were better performing. We selected on these morphological traits. Next slide, please. So anyways, on the basis of these morphological parameters, we selected 30 genotypes and we planted those 30, and then we identified the most best performing varieties. 5 or 6 we were identified, and fortunately, the problem which we had of the finding such a variety which is not creeping, which is not a creeping nature, we wanted to find a bushy type of plant which does not produce thread-like structures and which does not need the support to go on the maize plant, so that the farmers can use that bushy type of plant separately and they can grow in their field. Only the common bean crop can be grown so that they can get the better yield, and that yield is not compromised due to the maize crop. So these traits actually told us about their performance on seed weight, the pod length, number of pods per plant. All these traits are connected with the yield. So some protein on the basis of protein percentage, phosphorus percentage. So just I was talking to you that this was our luck actually. This was not that much science if I say that we did this. No, we didn't do this. From our 166 genotypes, we were able to find this genotype. You can see on the left side, this is a whole common bean plant. So it means that our hypothesis that we'll be able to find a plant which will not require some support, we found it. And you can see the yield there on the other side of the slide. These are the beans. It is early maturing. And when we talk about the climate change, before the onset of the monsoon are the problems associated with the rise in the temperature in August, this genotype matures 25 to 30 days earlier than the others. So that means it's early maturing. It means that when the temperature will rise, it will not be affected. And it will not require a lot of land resource and the physical support to reach to the maximum height. So it's a bushy type of plant. So this was very promising. This was our success. And meanwhile, we found some very high yielding varieties from Neelam. So you can see on the left, whole plant is carrying the pods. So it's very high yielding. Now what we are doing, we are crossing this very high yielding variety with the short duration variety or short statured variety, so that the high yielding character we can harvest from this longer plant and the short stature we can take from the bushy type of plant. So we have started doing the crosses. So this is the hybridization experiment. This is a very delicate crop. Its stamens are very delicate, its stigma is very delicate, and it has a big hooky type of structure. So it's a complex and tricky job to hybridize them, to pollinate them. So what we did actually, we we use the pollinated stigma actually to pollinate the emasculated flower. I'm not going into the details of technicalities. I know that many of you are from environmental sciences, but few plant breeders are sitting over here, so I have discussed with him as well, the rice research from the Rice Research Institute, Shah. A scientist is sitting over here. So we have discussed a breeding art, how we utilize the stigma, pollinated stigma, to pollinate the emasculated flower. हमें पौधे को female flower बनाना पड़ता है, and then we have to make it cross it through with the male flower. So we cross the male parts with the female flower to get the desired genotype. So since the flower is very small and its floral biology is a bit complex, so we use some tools to identify the ways to make the successful crosses. And it took 1 year to optimize the pollination, emasculation, and making the successful crosses for my students and for myself. So we use the magnifying glasses and some other tools to actually pollinate the plants. So these are some markers, which I'm not going into the detail. The genetic diversity we identified using the SSR markers. Now, ladies and gentlemen, what is the aim of this project? It is to facilitate the farmers. What are the aims of all the research-funded projects? Is to facilitate the communities. The research should not be confined into the laboratories. The research should not be confined into the thesis. The research should not be confined into the libraries. And especially when we talk about the applied research, and a research in a country which is developing, which is suffering from the shortage of money as well. So whatever the public money we have should be spent for the people and for the community. What we did actually, we took this research and we went to the farmer directly in the fields and we identified their problems. And the identified seed was distributed to the farmers in the hilly areas of Azad, Jammu and Kashmir. And this was the main success of our project, that we have not been confined into the laboratories. And not only our department of Biotechnology, University of Kotli and my students, but the Director, National Institute of Biotechnology and Genetic Engineering, we took him to the farmers in the mountains, and he is actually distributing the best seeds to the farmers in the hilly areas. And when we talk about these such projects in which the community should be involved, the people do not grow it. We went to the schools and colleges to give them the message to grow this crop, make this country self-sufficient, and by God, do not bring it from Ethiopia, do not import it from Ethiopia, an atomic power country with this largest army, with this beautiful country and resourceful country, is importing common bean from Ethiopia. This is a challenge for us. If this project is not helping this country to self-sustain in common bean production, it will be our failure. So we went to the schools, we went to the colleges, we went to the students and community to multiply this germplant, to use this common bean, to earn money and to make this country self-sufficient in this crop. And different colleges and schools and the girls and boys, they promised that they will cultivate it and they will utilize it and multiply the seeds. And you can see in the farmer fields we are experimenting it. We are not experimenting in the university. In conclusion, we have some promising genotypes from Azad, Jammu and Kashmir of common beans. We found some dwarf genotypes which have the huge potential if they are sown not with the maize but as a separate crop. They can yield better. They can make this country self-sufficient in common bean production. And the capacity building of the farmers we are doing for developing climate resilient crop, and we want to make the cultivation area increased. At the end, ladies and gentlemen, I will be sharing my poem with you, and this is not my poem, this is the common bean's poem. This is the common bean which is saying a message to you. And what message it is saying to you? I can climb on a stick, thread or a rope. I'm kidney bean, the grain of hope. Millions eat me around the globe. I flourish in fields and even on the slope. Princess of meadows, princess of meadows, I look like a queen. When in spotless white plate, often I am seen. I am the best in pulses. The wise are not wrong. With iron element, I make you very strong. With my proteins, I offer you some treat. I'm really the poor man's meat. I have minerals and lysine. Lysine is an essential amino acid which this carries and cereals do not. I have minerals and the lysine. Love me, O man. I am your beloved kidney bean. Thank you very much, ladies and gentlemen. So please, if you have any questions.
Assalamu alaikum, sir. Sir, first of all, thank you for such an excellent presentation. It was really knowledgeable. And so my question is, as you have mentioned in your presentation, that beans can't grow without maize.
With maize. Normally it grows with maize.
Yes, normally it grows with maize. My question is, it needs some research that what is the essential component which it extract from maize. That you have told us that in the presence of maize, it grows very good, but
No, I'm sorry. मेज़ के साथ ये ग्रो अच्छी नहीं होती, इसको असल में सपोर्ट चाहिए होती है. तो मेज़ के प्लांट को वो सपोर्ट लेके उसके ऊपर रैप करके चढ़ जाती है. उससे मेज़ की प्रोडक्शन भी कम होती है, इसकी भी होती है. इसलिए कि इसके हमारे पास उस तरह की वैरायटी नहीं थी.
मुझे ये कंफ्यूजन हुई थी, आपने कहा था कि मेज़ के साथ ये ग्रो करता है.
नहीं, चारा नहीं है फार्मर के पास.
जी सर.
कि वो इस सपोर्ट ये चूंकि उसके ऊपर उसको चढ़ना होता है.
मुझे लगा था कोई न्यूट्रिएंट उसे एक्सट्रैक्ट करता होगा, दोनों कंबाइन.
मेज़ को थोड़ा फायदा हो सकता है इस सेंस में कि ये नाइट्रोजन फिक्सर है. लेकिन मेज़ एग्जॉस्टिव क्रॉप है, वो बहुत सारे न्यूट्रिएंट्स ज़मीन से उठा लेती है. और कॉमन बीन थोड़ा सा इसका लीव्स और तरह के होते हैं, ये लाइट के कंपटीशन दोनों का होता है. और फार्मर बेचारा इसीलिए तो ये मुल्क इथोपिया से इंपोर्ट कर रहा है. हमारे पास वैरायटी अच्छी नहीं है जो कि अच्छे प्रोडक्ट.
जो मेज़ है वो इसके मुकाबले में ज़्यादा इजीली लाइट को और वो
मेज़ C4 प्लांट है, ज़्यादा लाइट ले लेता है. और मेज़ एग्जॉस्टिव क्रॉप है, वो एक पूरा पौधा होता है, वो ज़मीन से उठा लेता है न्यूट्रिएंट्स को.
थैंक यू.
Sir, your presentation was wonderful.
Thank you.
And as far as the concern about the exporting seeds from Ethiopia.
Importing actually. Export हम कर लेंगे तो फिर तो डॉक्टर साहब बड़ा मजा आएगा. Importing, yeah.
How we can overcome the import expenditures, which is in the form of foreign expenditures we are doing. As far as we have experience in the past, in the case of rice, when back in 2009, our rice crop was a bumper crop. As you can know well, basically it was a spot price announced by the government of Pakistan People's Party in 2009. As a result of that spot price, we got bumper crop of rice paddy. In Pakistan, as we were experienced in the 90s, Pakistan, Myanmar and India were the major countries in the subcontinent which were exporting rice all over the world and leading the other countries. And now we are doing that shift to the